So we said to select contact ID and count from the calls table, but we said group by contact ID. So what is that actually doing? So let's go back and let's do a select star from calls again. And let's look at this table. So this again is where it all starts. But with the group by, we are telling it, we are going to take all these rows and we are going to group them by something. In this case, we're going to group them by contact ID. So what Postgres actually does is it goes through each one of these rows. It gets to this first row and it says, have I seen contact ID 1 before? It says I haven't. So I'm going to create a new bucket or a new group for contact ID 1. And then in that bucket or group, I'm going to count. So this row gets passed into this count function. And it says, okay, so for the bucket defined by contact ID 1, we now have a count of 1. The next row comes in and it says contact ID 2. Do we have a group for contact ID 2? We don't, so we need to create one. So we create the group for contact ID 2. We feed that row into the count aggregate function and we say, okay, count 1. And the next row gets fed in. We say, do we have a group for contact ID 2? We do. So then we reuse that group. We pass that row into it. Now the count is 2. Same thing happens here. We already have a group, so the count becomes 3. And that's what we end up with here. There's the count of 3, and here's the count of 1. And we can do the same thing with all the other types of aggregates. We can say get the sum of things based on those groups. We can say get the average of things based on those groups. Does that make sense? Confusing? All right. I mean, you literally can think of it, like I like thinking of things in physical terms. So I'd be picturing this like if I had a stack of papers, each one was like a contact sheet of, this call sheet. And I'm literally stacking them in different stacks. Like, oh, well, this is from this person, so let me put it in this stack. This is from this other person, let me put it in this other stack. And we're literally just grouping them together.
Quick question.
Sure.
So in the calls table, contact ID 1 comes first, but how come in your output, contact ID 2 is showing up first?
So on one hand, I could say, I don't know, and I don't exactly. But the answer to that is when we talked about order by before, order is undefined. We did not tell it what order it should come back in, so it could come back in any order. I mean, if we dug into the Postgres source code, it is a deterministic thing. I mean, it is a machine. It's not like there's like quantum randomness or something going on. But as far as we're concerned as the users of it, we didn't tell it the order, so how it determined what order that came out in, who knows?
I think that's maybe like to flip that around, a good a good truism for any database work is that if the order matters, then say what the order is, right? Like, and that's just like any kind of programming where you're selecting things. Like, if you're not ordering, something's gonna order it, and you don't necessarily know what that something is. If the order matters, then say what the order is.
Right. Yep. Yeah. I mean, it is deterministic, but it'll be based on, just the details of how the ordering and grouping, or how the grouping and aggregate functions are actually implemented internally, but it's not something that we can rely on or should rely on.
And Jack, here, deterministic, you're meaning like there is some kind of rules that determine how it works.
Right. Yes, it's deterministic, but it is not predictable. Or rather, I mean, it's not predictable by us. Let's put it that way. Huh. Okay, what went wrong here? It's screaming at me again with error messages. So what is it telling us here? Column calls.call start must appear in the group by clause or be used in an aggregate function. Okay, so it didn't like me saying call start. So I can take out call start and it'll probably work. Yeah, it works. So it's telling us, you know, oh, it must be in the group by blah, blah, blah. But let's think about this for a second as to why. You know, why doesn't this work? Why can't we include the call start in these rows? Yeah, exactly. Luis is exactly correct. We have multiple call starts. You know, we have 4 calls, and we're only grouping it in 3 buckets, or 2 buckets rather. So, like, which one of these call starts do we use? Do we use the earliest? Do we use the latest? Do we use the middle one? Do we average them together? Who knows? And since we didn't tell Postgres what we wanted, we specified an ambiguous or a contradictory even question, and it says, I can't answer that until you form the question better. So that's something you'll run into fairly often sometimes when you have a bunch of values and they need to get somehow squished down to 1. And there's a lot of ways we could do that. I mean, we could say, you know, least and greatest, I think. No, it's min and max. Least and greatest is the other one. You know, we could say, yeah, give me the first one, the minimum. Or we could say, give me the last one, give me the max. Or we could even, I think we can even average times together. I think, no, can't average times. I guess that makes sense. But we have to tell it, how do I reduce many things to 1? So this here is just an example. We've already talked about this, but yeah, we can do many aggregate functions at once, no problem at all. And now to go back with our, to kind of bring a bunch of these things together, we can combine joins and we can combine aggregate functions. Again, this is getting long enough that I am just copy and pasting occasionally. But it is good to, this typing it out does force you to slow down. So it is useful to do that sometimes.
All right, so I just wanted to seek clarification on something.
Sure.
I was going back to when you did select contact ID, count star from calls group by contact ID.
Okay.
I think where I was getting tripped up was when I see star, I think that that's every value in every column in every row. So what exactly is it counting in that step?
Sure. So it's, I guess you'd call it a special form. I'm not sure if that's the exact technical term that the internals would use, but it's counting rows is basically what that means. Unfortunately, the star is used a little differently, where if you're doing it outside of, the count star, it means give me all the columns on all the tables, like you said. But inside of count, it means count the rows.
Gotcha. Okay, thank you.
Mhm. So what we're doing here, we're combining group by with aggregates, and we're doing a join between contacts and calls. So where previously we were seeing like, hey, we spent 52 minutes on the phone with contact 2. It's a little more meaningful to say we spent 52 minutes on the phone with Lydia. And we have to join them together to get the name. Now I'm going to run through kind of what we're actually doing here again, just so kind of visualize what this is actually doing. That's a big part of successfully writing SQL, especially when you get into stuff with joins and aggregates, is being able to visualize what's happening, what the database is actually doing. And a lot of times I kind of think of it as a bit of a funnel. In fact, several funnels. You could think at the top of the funnel, we have all the possible rows. And in fact, let's start there. So where the database actually starts is cross join calls with this, what we looked at before, where we have all 76 possible rows. It starts there, but we don't actually want those. So then we filter it down to just the rows where that join condition is true. Okay, now we've got this table, these two tables joined together. But now we're going to group it. So what happens when we run this group is it's going to look through each one of those rows, and it groups by the contact ID. It groups by the contact name. And it uses that to define what are the buckets or what are the groups. And then for each row, once we know which group or which bucket it goes into, we feed it into these aggregate functions. And that provides the final output of, okay, there was one call for Miranda, there were 3 calls for Lydia, and so on with the sum and the average. So I know we're kind of putting together a lot of different new concepts here. Presumably, some of this, it's the first you've seen in the last hour or so. So let's review this a couple times here. So let's just start back here. So these are all possible combinations. So first step here, we've got 4 rows in the one table, we have 19 rows in the other table, and
So Jack, before you go back into that explanation, my brain was trying to come up with why, I think I'm just looking at this wrong. You did that example of select contact ID, call start, and then that was to basically tell us you can't aggregate call start and it's not in the group ID. And then the very next thing you went into was multiple aggregate functions can be called in a single query. So my head was saying, okay, this is a fix to the previous problem, but I think it was just a different topic. Is that right? Or am I missing something there?
No, you're correct there. It was a different topic. That was just an example of, we might want to do that thing where we included, let's see, where was it? Here, I guess. Yeah, I guess this was back. Yeah, it was back to this one. We might want to do this, but it doesn't work. So that was kind of just showing if we go down that path, it breaks. So we have to turn around and go back and do something else.
Okay, so no relation between the two. Okay.
No relation.
Okay, got it. Thanks.
Okay, so again, to look at this stuff here, and don't be surprised if it does take you a number of times to see this before it starts to make sense, and then a number of times more before it kind of becomes second nature, because it's not even just like programming. This is just a different way of doing stuff than Python or JavaScript or pretty much any other language. You know, this is a set-based language. And I mean, APL is array-based, but I mean, who uses that? Aside from that, I can't think of any other language that's works primarily in sets. I mean, can you think of anything off the top of your head, Jake?
I haven't really encountered any language like SQL other than SQL, I think, in my career.
Right, yeah. Certainly nothing that's actually in any sort of mainstream use. So definitely, don't feel surprised or, get discouraged if the first time you see this, it looks like really strange, because probably you've never worked with anything else like it. So it's kind of to be expected.
Yeah, one thing that I sometimes think can help is that the order the clauses in a typical SQL query are maybe not like a best arranged for thinking about. So if I was to take a query like the one on Jack's screen right now, it's like select so-and-so. Yeah, he's kind of going where I'm going. It's like select so-and-so from this group by. You could think about it in the sense of like, yeah, I'm not sure. Is that how you would picture it there, Jack? From context join.
Yeah, that's the order I would think about it in. It's mostly in order, except select should come last in general. A few little exceptions, but
yeah, I think starting with from sometimes and then ending with select can help make it a little clearer. It's like I'm taking the data from this table. All right, that's where all the data is coming from, and then you can kind of like gloss over the join for a second, but like, and then it ends with select. It's like, what do I, from the data set that I've created, what do I want? I want the ID from contacts. I want the name from contacts. I want a count of the set. I want to sum the call duration. I think sometimes the way that SQL is ordered, it's hard to like visualize it.
yeah, it's definitely not ideal. And this is one of those side effects of them trying to make it be like English, because it definitely doesn't read as a sentence near as well to say from contacts as it does to just start with the verb, from, like what is that, a preposition we're starting with that? It doesn't read as well. What's also really annoying, we talked about tab completion. That's also part of why tab completion is really not so great in SQL, because when you're typing the select, it doesn't know where it's coming from yet. So that's kind of unfortunate too. Let's see here. Okay, so yeah, we'll pretend we're the database one more time and think about like how this query here is actually being executed by the database. So it starts with, it has, both of these tables, like all the contacts, we have all the calls, but somehow we need to join them together. So that's where we end up. The next thing is cross join. So here are all the possible ways these rows could be put together. But we don't want all the possible ways. That's why we use the join with the on clause here, where we say the only rows we want are the ones where the ID column of the contacts table, so that would be this column here, is equal to the contact ID column of the calls table, which is this column here. And every row where that's true, we want to let it pass through this filter. Every row that's false gets rejected. So once we do that, we end up with just those 4 rows. Now we have these 4 rows. Now we've kind of evaluated the entire from clause here. So that's what we're saying, like Jake was saying, the order is a little messy. This is what actually happens first. Okay, so we've done this. This is the set we have. Well, we need to group it. So we're saying group by contacts ID and contacts name. So every one of these rows is going to be evaluated based on which group it appears in. So we're going to say contact ID and contact name. Have we seen contact ID 1 and Miranda Carroll? We haven't. So we're going to create a new bucket. In that new bucket, we store the contact ID and the contact name. We then say, okay, count this. So we're going to increment a counter that says, okay, there's now 1. We're going to sum the call duration. So we're going to add that to a summation. And we're going to average call duration. So we're going to keep track of the sum and the counter inside of that. The reduce function will have its own internal state. Then we go to the next row. Have we seen, ID 2 and Lydia before? We haven't. So we create a new bucket. In that new bucket, we keep track of the count. We feed in the row. So, okay, that counter goes up by 1. We feed in the call duration. So it sums that. We feed in the call duration. It averages that. We go to the next row. And we already have that bucket. So again, we feed in this row, into these aggregate functions. We do it again the 3rd time around. So we only created 2 buckets. So we would expect 2 buckets to come out the end, or 2 rows. And then the final value at each of those aggregates. Let's see, Alicia, I'm not sure.
Alicia, yeah. So I think part of my confusion is that in this case, at least, we won't ever have a difference, or we don't currently have a difference between the name and the ID, right? Like Miranda and 1 are always going to be the same.
Right.
So it's almost like there's 1 group, even though you put 2. So when would you, and how would it look if those were actually different values?
Okay. Yeah, let me think of an example for that. Okay, well, I guess to explain what's happening there is, it so happens that they will always be the same. But I was going to say Postgres doesn't know that. It actually does. So to be precise, we could actually do this. There is it's kind of like a shorthand where it knows that group, but I don't want to, I wanted to just spell it out longhand. I was trying to make it clear. Evidently that part didn't work there. But for how it would look differently, let's see, do we have anything like that in our current database? Let's see here.
So what if you added, I don't know if this would work, but what if you added another call duration that was the same length of time, and then you sorted by either name or ID and call duration?
Well, I don't think that would affect the group by part, unless I'm misunderstanding.
Well, I'm probably the one misunderstanding, so I think that's fair to say.
I know what you're asking about, defining the group based on the 2 columns. I'm just trying to think. I don't think we have any examples of that in the data for this one. I'm trying to think of what would be a real world. Okay, what would actually be like a real world example of grouping by 2 columns? It would be if we were grouping people by their address and we wanted to group by state and city. That's the type place where you would actually group by 2 columns, and the it would be a little more meaningful. You have many cities in one state, and like Springfield, there's probably a Springfield in like every state in the union. So you'd end up with you couldn't group just by city name, and you couldn't group just by state name. You'd have to group by state and city if you actually wanted to group by the actual distinct cities.
Okay, so I think, thank you for that example. I think that just explained it. So I think, and I'm probably not going to explain this correctly, but so you're basically saying for any unique values of in both groups, create a bucket. So like your example, right? You have Springfield, Texas, that's going to be one bucket. Springfield comes up again, but now it has to check the state. And if it were Texas, okay, it goes in that same bucket, but no, it's not Texas. Now it's Virginia. So now that's a new bucket. So we have Springfield, Texas and Springfield, Virginia. Is that right?
Yes, exactly.
Okay.
Yep, you got it. I think I saw another hand earlier. Do we have any other questions before we move on?
Oh, that was me. I had the same question.
Oh, perfect. Yeah, and like I said at the beginning, I really do want people to speak up and ask questions. Jake and I have, this might be the 10th or 12th time we've done like a SQL workshop, and if we don't have like interaction and people aren't asking questions and we're explaining things, I mean, there's no point in us even doing it. Just watch the video from last year, So we're here to answer questions. So that's good. Okay, left join. This is a new thing. And this is another, I'll just tell you ahead of time, this is another one that's probably going to be a little confusing, but we'll do our best to explain it. So when we run this query, you'll notice that the question that we're kind of asking here is, give me the name of everybody we talked to and how many times we talked to them and how long we talked to them. Maybe I'll shrink this one a little bit. Maybe, if we were just to say, how many times did we talk to them on the phone? Well, we have a bunch of friends that aren't listed here. And it's because we never talked to them. So our question here, if we want to ask the question, how many times have we talked to each of our friends? Well, we asked Postgres a question, but we didn't ask the question we thought we asked. I want to know how many times have I talked to each of my friends. What I actually just told Postgres here is how many times have I talked to the friends that I have actually talked to. So in other words, we missed all the friends that we haven't actually talked to at all. And we can see why that happened if we go back to our, where we were kind of stepping through step by step here. Remember, I'm not going to drag you through that 76 line thing originally that we filtered down. I think we probably got that. But you know how we ended up with this? Well, that was because we had those 76 lines and we only included the lines or the rows where those, contacts.id equals calls.contactID, and we filtered all the other rows out. So by the time we get to counting how many calls there were, there's no row. Like, how do we count 0 things? But if I give you, that idea of like grouping stuff into buckets, if we say, let's say we're going to group, we're grading papers in a classroom, and we're gonna we're gonna put each paper in a stack for the alphabetical thing. So all the last names that start with A are in one stack, and all of them that are B are in one stack, and all of them are C that are in one stack. What happens if we don't have anybody whose last name starts with X? Well, we're not going to have a stack. So what does it mean to say there's like a stack with 0 in it? Well, there's no stack, or there's no bucket. That's a problem that comes up a lot in SQL. And the solution is a left join. So I'm just going to change this one here, and I'm going to change this from join to left join. Now this is different. This is a lot different. So here's what left join means. Left join means the table on the left, and you can kind of visualize that a little bit more if you actually look at it like this way. I usually split the joins up to one table per line, but the left part like really makes sense here. The table on the left, the contact one. We are saying, I want every row from the table on the left. Now, if there is a row on the right that matches based on this on clause, I want, again, I'm talking to Postgres. I want Postgres to match this up here. But if there is no match, I still want the row on the left. Just leave the row on the right blank. Yay? Nay? Does that kind of make sense so far?
Yeah, makes
Yeah.
sense.
Cool. Okay. So now if we were to run this whole query, again, the only thing we actually changed, the only thing we actually changed was adding that left. And the only thing the left changed is we now get these rows back where we didn't. We already had these rows because they match. Now we also get all these rows. All right, let's run this and see what happens.
Did we have a raised hand?
Oh, I'm sorry, I missed that. Yeah, go ahead, please.
That was actually I didn't realize you didn't do that actual line yet. I was just curious as to why yours was like filtered, but I get why I didn't. Thank you.
Cool. All right, so we run this here. Good news, we do get a row for each one of our friends. Bad news, we got the wrong answer. It's saying we talked to each of them once. And that was the whole problem. We didn't talk to them at all. And now it's saying, before it ignored the row altogether, now we got the row and we got the wrong answer. Good grief, this stuff is hard. Okay, so what's going on here? Well, before we answer that, or to make answering that easier, we are going to go back and talk about null. So null is another one of those. Sadly, I'll tell you ahead of time, null is one of the most confusing things you'll run into in SQL. If you can remember a few ideas about it, it'll make your life a lot easier. But if you forget them, and even if you remember them, occasionally you're just gonna find yourself, kind of slapping your forehead. Or null is kind of a foot gun in SQL. But okay, so what is it? So I am going to stop sharing the screen for a second. And see, so can you all see me again? Yes?
Yes.
Okay. So I've got a couple of just random things that were sitting on my desk. I got an old USB stick and an SSD. And they're both conveniently sized so they can kind of fit in my hand. So is this equal to this thing?
No.
No.
Nope. Yeah, it's not actually a trick question. It's like, no, they don't, they're not equal. Is what is in my left hand equal to what is in my right hand?
I don't know.
Well, you just solved it. If you remember that that's what null means, you're done. You've got it. Null means I don't know. That is the only answer that is possible. Because, it might be, like my hands might be empty. Maybe they're equal in that they're empty. Maybe one is empty and one has something in it. Maybe they have something different. But until you look inside, what it means, null literally means I don't know. or it means unknown. And it also can mean empty. That's why it's really annoying, because in some cases or some contexts it means it's empty, but in other cases it really means I don't know. But if you remember, those are the two meanings of it. Everything else, you know, all the other weird behavior that we're about to find out about with null, everything else comes from that. So to put it back in SQL, if we just do an expression here, if we say, does true equal true? Well, true, yes, it does. Does true equal false? False. Does true equal null?
Do you want to share your screen or?
Oh, I'm sorry. Yes, I do want to do that. Thank you. Let's see here. Yep. Okay, so yeah, these are the examples I was given there. So true equals true is true, true equals false is false, but true equals null is null. We can't say it's false because null is one of those things that means I don't know or unknown. So maybe the unknown value really is true. So it's not fair to say, oh, it doesn't equal, because maybe it does. So null is infectious in that manner, in that whenever a null gets stuck into a calculation, everything kind of cascades to null. So like, what is 1 plus null? Null. You know, what is the length of null? Null. You know, what is, you know, is 1 greater than null? Null. So all these things, if whenever you see null in these contexts, if you replace it with unknown value, all of a sudden it makes sense. You know, what is the answer to 1 plus an unknown value? An unknown value. You know, what is the, you know, is 1 greater than an unknown value? Well, that's unknown. You know, so again, if you remember, empty and unknown are the two meanings, and the unknown part really makes things messy. You now understand null.
Yeah, there's a little, did you do null equals null, Jack?
Oh yeah, you know, I didn't do that. You're right. So does null equal null? Well, no, because that's actually the same thing that we had when I just held up my hands where you couldn't see what was in my hands and asked, is what's in my hands equal? Well, is one unknown thing equal to another unknown thing? It's unknown.
Yeah, Postgres has a little trick for this, which is, you know, cool or bad depending on your perspective, but probably good. But like you can say it, you can replace equals with is, and that's, I guess I would describe that as like, is it the type of null? Yeah, I think, I mean, you could also just do like select null is null, should return a Boolean. I don't know what the difference between that and is not distinct.
I guess is just the shorthand. I always like spell it out. I mean, to be honest, you taught me something right there, Jake. I always do the longhand. That's crazy that I've, or actually, oh, you know what it is null is actually, that's a special form right there. It's is null and is not null. That's a predicate. But yeah, if you were actually comparing two unknown things, like if you were actually saying, does A equal B, and A or B could be null, you would actually do this whole number. You would actually spell it out that way. Yeah,
someone was asking about Jack's null character. That's correct. It's set up in the P-SQL RC that he shared. And why would you do that? Well, if you don't have a character for null, then it shows like I guess it's an empty string.
It doesn't print anything, so there's no way to tell the difference between that and empty string.
Right. So I think that's a pretty essential Postgres setting. if you want to know that something is null versus like wondering if it's null or an empty string.
Yeah, for example, here, I'll just load up PSQL without the my RC file. Which one is null and which one is an empty string? Versus with that setting.
This is like a point worth making here, I think, is like null. I think Jack's dissection of this concept here shows that like null can be really sneaky because it, as you said, it kind of affects everything else. So the is trick that I was showing, or the is not distinct, is great when you want to know, is the value of something null, right? Is the field in, is the column in your table null? But we have, I think, a good like approach is to try to like not let things be null very much, because once they're null, or once they can be null, you know, you get into this problem really quickly.
Yeah, one of the things, if I remember, I'll post a link to it in the Slack later, maybe at our next break. There was a really funny and really good article that showed up on Hacker News and on Reddit a couple days ago. It's called Grug Brain Developer. But it's pretty funny, but the core idea of it is complexity is the enemy. And the idea is our brains are too small to keep track of everything at once. There's just way too many things to think about. So anything we can do that means we have to think about less things, that's good. So null, whenever a null can be in the case, we have to stop and think, oh, is this empty or is this unknown? And what is that going to do to anything that I'm calculating with it? And you have to stop and think. Whereas if you say this column is not null, you never have to think about it again, because that case can never happen. So anything that prevents you from having to remember things is definitely good. I saw a question about using pgadmin. That's fine. Yeah, I don't particularly have anything against them. I just end up liking command line tools, you know, because they're scriptable. I mean, PSQL actually has like a mini scripting language built into it, and it can do, you know, it's actually maintained by the Postgres core team. So like everything Postgres can do, you typically can do through PSQL. And it's always available everywhere. You know, anywhere you're going to use Postgres, you can have the PSQL thing. So it's kind of more just personal preference. I mean, if you want to use, you know, pgadmin or, you know, some sort of other graphical tool, you know, go for it. They're definitely better for exploring. That I'll definitely concede. Okay, so back to why this didn't work. You know, we had our query here, and we ended up with 1 for the count. So count, the actual count aggregate function, it counts non-null values. So just like sum takes, you know, some sort of number that it adds together and averages things together. Well, count does take something. It's just, it doesn't care what it gets. As long as it's not null, it counts it. Well, star means the row. Well, if we look back to, let's see here, this, well, we never talked to John Smith, but there is a row for John Smith. So it counted the rows. And it's right, there is a row. So to fix this query, we really don't want to count the rows. What we really want is to count the call IDs. Because if there was no call, the call ID is going to be null. And if it's null, it doesn't count. So if we go back here and we change this to calls.id, now our count is 0 where it should be. Any questions on that? It's kind of confusing the first time you see it.
Can you just show where you changed it again?
Yeah. So instead of count star, we had this, and we changed it just to calls.id. And with that, instead of it trying to count how many whole rows did it get, it tries to count how many calls.id did it get. And null doesn't count, so it ended up with 0 for most of these groups.
What is the difference between oh, never mind. So the dot is table dot column name and the underscore is just column name, right?
Yeah. I should have probably specified that a little more. So yeah, it's table dot column name. The table is only necessary if there's an ambiguity. So like here, call duration only exists on one table, but ID actually exists on the contacts and the calls table. So I have to disambiguate it here. And I'm not sure why I typed it out here. It's unnecessary on these two. Dalton?
I don't know. I think I've kind of got lost. I'm just trying to, so the call duration is on the calls table, correct?
Yes.
Where, so I don't get where in that select statement, where, like, is it just because you're joining calls? Is that why it works, I guess?
So like what? Yes. So we start out with this stuff here, and then all the columns from both these tables are available for us to use in the select statement and the group by statement. So this makes it available, and we use it here.
Okay, so is it almost like kind of nested where like it does I guess it kind of goes into the nest, and then it has to go back around, or does that make sense?
Well, I'm not sure what you mean by nested there.
I guess I don't know. I guess when I like look at this, it kind of makes sense, but the way like I see select all that, and then I'm like, but how does it know to take it if it's not for 2 more lines that you actually make it accessible?
Oh, yeah, that actually goes to what Jake and I were talking about a little earlier, where the order that you type this stuff in isn't actually the order it happens. And that's kind of confusing. It really happens in this order.
Oh, interesting. Cool.
If you wanted to, I think this is true, right, Jack? For call duration, you could say calls.call duration too, if that
Oh, yeah.
if that helps. But Jack is leaving that out because Postgres, when it can, it will it's like, well, there's only, you ask for something called call duration, and I've only seen one thing that's called call duration, and it's on this table. But sometimes, so that's like a convenient shorthand, but sometimes I think it maybe hides what it's doing a little bit.
Yeah, we only need to prefix it with the table name to disambiguate. So like ID here, we have 2 different ID columns. We have to tell it which one do we want, but we only have one call duration. So let's look at this one last coalesce thing here. In fact, I'm just gonna I'm actually going to simplify this even further. So sometimes you have a null, and what you want to do is, if I have a null, I want to use something else instead. So there's a function called coalesce. And what coalesce does is it returns, you can pass it any number of arguments, and it returns the first one of them that's not null. So we can have any number of nulls here, but we'll still get the first thing that's not null. And if we happen to have, you know, something like this, we can use that as an expression. So just to glance at this quickly, you may have noticed that even though we fixed the count of calls being 0, we still had null for how long we talked. By using this coalesce here, we can change that sum and that average to be zeros. So finally, we end up here with, you know, not just how many calls did we have being 0, but we talked for 0 amount of time. The average amount of time was 0, and so on.
So when you use coalesce, does that update the table itself or just for that particular call instance?
Just for that expression.
Okay, thank you.
Sorry, can you just explain that one more time, exactly what it does? You don't have to like just verbally explain it.
The coalesce function, you mean?
Yeah.
Okay, so coalesce is a function that takes any number of arguments. So we could say, you know, it could take one, well, it doesn't make sense for one, but 2 or more is actually what makes sense. We could say, you know, anything we wanted here. And it returns the very first one that is not null. So it's also, you could think of it as shorthand for saying, if this is null, do something else. And, you know, if it's null, use this other value instead.
So when would DEF get used in that scenario?
In this one, it never would. This would typically, the way you would see this is, you know, instead of explicitly being null, it would be, you know, some sort of column value. Like, let's say, you know, we were select star from people or something like that. So we would say name, and then maybe we just want to print out the word unknown if the name is empty. That would be the type thing you would use it for. It's very rare to use it with more than 2 arguments. But typically in that type case, you would not be using literal values. You know, you wouldn't actually be typing in values. It would be, you know, coalesce column A, column B, column C, or the text unknown. And that would give you, you know, if A is not null, then do A. Otherwise, if B is not null, then do B. Otherwise, if C is not null, then do C. Otherwise, use that last bit of text. That would be the type thing you would use it for.
Yeah, it's almost like a presentation thing in this example, because let's say you were like to print out this table and somebody in your team was like, hey, tell me about the calls we're getting. You know, by printing that value, you're like making the data like make sense to a human, right? It's the sum of the time, but if there's no time to sum, then you're showing something that's like a logical thing to show.
Right. In JavaScript or Python, it's basically the equivalent of the double pipe of the OR operator. You know, where you're saying this or this other thing. So if null comes up, then try the next thing, then try the next thing, then try the next thing.
Got a hand raised.
Okay, Michael.
Yes, sorry. So when I ran that block of code, the coalesce one, I noticed that the title of my columns that use coalesce all just turn into coalesce now. So is there a way to make it so it says like, you know, sum, count, and average instead of just coalesce?
Yes, there is. So good question. So if you say as, and then type an identifier, it will use that as the name.
Okay,
And-
perfect.
Yeah, and this is also a case where the double quote sometimes comes in handy, because this is where you could say like, you could use spaces or something like that. And to be completely detailed and precise here, the word as is unnecessary. If you wanted to leave it out, you can. And it'll figure out what you meant there. But that's a rare case where, to me, I find the additional readability worth some additional typing. So I typically would actually use the as keyword there.
Thank you.
Mhm. Cool. Any more questions? All right.
Yeah, I do have a question.
Okay.
Unless you're going to talk about this like in a future lesson or something, what's exactly the difference between using join and full join, if there is a difference?
And full join. So full join or a full outer join would actually be the long wording of it. Well, I guess the way to contrast it is left join says, give me everything on the left and join to the thing on the right if you can. There actually is a right join, which is rarely used because you can always just change the order of your tables. But right join is the exact opposite, where you say, give me everything on the right, and if you can, match it up to the thing on the left. Full join says, give me everything on the left and everything on the right, and connect them together if you can, but give me everything on both sides regardless.
Yeah, I mean, I think my question was like, what's the difference between just using join by itself and using full join? Since full join connects everything as well, but join also connects everything, right?
Well, let's see here. So the difference, and to be precise, I'm not sure if there's shorthand for this or not, but when I'm thinking of this, I'm thinking of full outer join versus inner join. The difference is the normal inner join will remove rows. So if there's no match, it removes the row. But the full outer join says try to match it, but if you can't match it, include the row anyway.
Hold up. What?
So like, I think an example of that would be like, let's say there's 7 people in table 1 and then like 10 locations. The outer join would include a total of 10, right? Like assuming there was only one unique match out of those 7, it would include the last 3 as well, whereas the inner join would only include those 7.
Okay, so could you go to line 162? So join, so just using join by itself, is there a difference between that and actually just using full join?
Let's find out. Yeah, the difference here, if we go back and forth between this. So just like join is shorthand for inner join, full join is shorthand for full outer join.
Okay.
But the idea here is, this only gave the rows that match. This gives all the rows on both sides and matches them if it can, but if it doesn't, it still gives us the non-matching rows.
Well, okay, so actually join is shorthand for, okay, I didn't notice that at first. All right.
Right. Yeah, outer joins like that, or the full outer join. I mean, that's the thing. The outer is kind of a word you don't have to use. Like you can also type like left outer join if you really want to type extra. But the difference the full outer join is rarely used. I mean, I would say I use it less than maybe like 1% of the time. But like for a only semi-contrived example, pretend you had a table of teams and you had a table of players. And you want to get a list of every player with every team. Well, you might have a team that has no players, but you still want the team to show up. And you might have a player that has not yet been assigned to a team. So you want the player to show up. So the full outer join says, join them together if you can, put them on, match them up based on team. But if the team doesn't have a player, I still want to see the team. If the player doesn't have a team, I still want to see the player. That's the type thing that you'd use it. And like I said, that's pretty rare. Cool. All righty. Let's take Caleb, sorry.
I just had a question, taking this a step further. After, you group the calls and everything, can you then also use order by, or is that like too much logic for it to handle?
Oh, no, you can totally use order by. You can. Yep, can totally do that.
Okay, awesome. Thank you.
Mm-hmm. All right, let's take a break until 2:10. Then we'll do one more set of exercises here, and then we'll get to some data modeling. So we've got about another hour in P School, and then we'll do more whiteboarding type stuff. We are going to move on from the phone book example. And we've actually got 4 like major like lesson groups. And like I said, we got far more than we have time to do. We're gonna, well, I'll give you the tour of the other ones or a little bit of description. So we've actually got a COVID-19 database that has a bunch of statistics, which can be really interesting, like querying real world data. Unfortunately, it's kind of depressing querying real world data about like hundreds of thousands of people dying. So I don't really feel like doing that right now. We also have a time clock one, which is pretty interesting. If you want to have a SQL idea of data modeling, which will probably make a lot more sense after Jake's presentation and interactive like workshop next hour. So we're just going to do a little bit of querying on some weather data. So we are going to, in our terminal, we need to leave the phone book directory. So we're going to cd ... go up a level, then go to the weather directory. And we are going to create a database for weather. We're going to import the data just like we did before. And this imported a lot more data than we did in our phone book. So we're going to run pSQL weather. And let's just take a look around here. So try hitting just \D on its own. This will give you the list of relations. And in this case, we have two tables. Now, \D, well, actually, let's talk a little bit more about / commands. There are a lot of them. So if we were to hit / and question mark, pSQL will print out some help and tell us all the different things it can do. And like I said, there are a lot of them. And in particular, there are a lot of these describe ones. So we've done this \D. Now this is actually another interesting thing. Are you all familiar with like when you're in like a syntax description like this, what it means when you have like square braces? Yeah, I don't think that I ever like had it explained to me. It was just something you kind of see a bunch of times and then finally look up and then like, oh, that's what they meant. So we see it here. You can also see it if you look at the Postgres docs for just any given command. Like let's just take a look here for a second. So you notice there are a bunch of these here. So when you see something in square brackets like this, that means it is an optional word. Now it's not optional as in it's meaningless, but it's optional in that, you know, the command is valid without it. Now, obviously there's a whole bunch of different things going on here, far more than we want to go through. But in this case here, it's saying you can just say, you know, \D, but you could add more to it. So like, for example, where's DT? So DT tells us to list tables. So this will give us just the list of tables. If we add the plus, it gives us a little more information. For example, how big is this table? That's actually kind of convenient. And you'll notice the S there that was optional on a bunch of them. Now we're looking at a bunch of system tables. Now, normally we don't actually want to see those. That's why it's optional. But poking around at this occasionally can be really informative because there's a whole bunch of things you can ask Postgres and it'll tell us what is actually in my database here. It also will tell us about the help command for SQL. Now, most of the time nowadays, you have the internet available, so you'll just use your web browser, but it actually has basic help built in. So like we were looking at the SQL thing on the web browser. Well, this looks an awful lot like this. Doesn't have all the details, but it gives you the core syntax and it tells you where you can get more information.
Yep. Taking some time to like try to learn how to read these is actually really pays off a lot, I think, because it tells you right here everything that select can do, and this it looks like a lot, but there's a language to it, and it's your version of SQL. It's not like something you found on some random blog post where someone is writing about Postgres 9 or something. It's like, this is what works on your machine right now. There's another benefit for that, for doing it this way.
Right. And to read it, like I was saying, like the squares, when you're seeing this type syntax description, the square brackets mean this is optional. If you see the pipe operator, the vertical pipe, that means or. So we're saying here, like you can say select all or distinct. You can't say both words, but you can say either word here. If you see this, here's a thing, like here's a simpler one here, maybe. Yeah, grouping. So remember we did like group by ID, comma, group by name. One of those is required, so we say grouping element, but then when it's followed by squares with comma, dot, 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 that's saying this entire thing here, we need one or more of them, and they're separated by commas. If you see a curly brace, this is saying it's saying it's an exclusive or. Let's see if it's saying it's required exclusive or is actually what that's saying. Think through that for a second there. But yeah, I mean, we don't actually need these like right now, but knowing how to read that does come in handy sometimes. Okay, so back to this. We're going to do \d and see, okay, we have a reports table, we have a stations table. So let's look at the reports table. Okay. We have a bunch of IDs, the ID for the report, the ID for the station, we have the time, we have temperature, humidity, wind speed, wind direction. Let's see what the stations have. Okay, ID, name, elevation. Okay. And let's just look at some of this data, see what we got here. So select star from stations. Okay, we only got 2 stations. And how about, what do these reports look like? All right, well, we got a lot of reports here. This is where having a pager is, kind of useful, seeing as 220,000 rows. This would kind of have buried our terminal if we ran this without the pager. Okay, so we're actually going to let you do a couple of these exercises here. I'm going to give you all about 3 minutes to go through as much of these exercises, whether you get through 1 or half of one, or you get through all of them or whatever. Give you about 3 minutes here, and then we will go through them together. But you learn by doing, so let's try and do something here.
So quick question, in my terminal, it looks like it's cut off horizontally. Is there a way to see
So,
everything?
yeah, if you are still in the pager, your pager should let you scroll left and right with the arrow keys. If you're not in the pager anymore, it's gone.
Pager meaning what again?
So when you, like, if you do the select star from reports, I'm
Yeah,
assuming that you probably see something with like a colon at the bottom of the screen.
well, right now I'm looking at my result from that.
Right. Well, I mean, when you run the select first, let's see, can I do this here? Pager. Will this work? How about that? Wow. So I'm guessing you're probably looking at something like this now.
No, I still have the weather equals hashtag. So I just did select star from stations, colon,
Sure. Okay.
and I see exactly what you see. But I couldn't go left or right.
Okay. All right. I think I know what's going on then. So let me just make this window a lot smaller. So you might end up with something like that where it does some sort of weird wrapping. But if it doesn't, if you don't have to hit like Q to bail out of it, if it just immediately, you're back here ready to type, there's
Yeah.
no way to scroll once it's like just printed out to the terminal. If you are still in a pager, that's like what we see here, where we can scroll up and
Right.
down. If you're in a pager, you can go left and right, but if for whatever reason it's not in a pager, it's just gone.
Got it. Okay, thank you.
Mhm. Okay, so for this first exercise, find which weather station has the highest temperature record. So if we want to even just think about this, like how would we do this even if we didn't have SQL? If we just had a stack of papers of, temperature records, how would we do this by hand?
You just have to keep looking at looking at the temperatures for each station and try to find the one that has the highest.
Yeah, pretty much. So our equivalent in Postgres will be, to start with, we can look at all the reports and we can order by the temperature descending. And then we can limit it to one row. So we just get the most recent, we just get the hottest row. Okay, so the hottest row we have was 103 degrees. Now a station ID isn't too handy, so we would actually need to say select star from stations where ID equals that. All right, so to answer that question, it was O'Hare. But it'd be nicer to do that in a single query. So we could do that in a single query if we did a join. Now, I'm getting a little tired of typing into the pschool prompt. So we're going to learn a new pschool thing, and that is how to tell pschool run a file instead of having to type it in, run a file. So I'm just going to copy this back in here. So I typically call these temporary SQL files just t.sql. Just, you can call it whatever you want, but that's about the minimum typing you can do. So \I for input, and then you type in the file that you want it to read and execute. And it reads and executes it. So when I'm doing anything more than like a really pretty much more than a 1 or 2 line query, I almost always actually use a separate file. And I do that so I can take advantage of the syntax highlighting in my text editor. I use Vim mode, so I can, use the nice like word by word navigation, all that sort of stuff. And it's just altogether just a nicer editing experience. So I suggest you all do that as well when you're working with, again, anything longer than a line or 2. Just create your own temporary file and just keep re-importing it. Now for this question here of how do we match these stations? Yeah, Dalton?
Yeah, I put mine in, oh, did you put it in weather or data, and does it matter? I think I put mine in data and it's saying no such file is there.
Yeah, it should be. Well, in particular, it'll need to be in the same directory that you're running your pschool from. So if you followed along like the way I was doing it, yeah, it would need to be in the weather directory, not in the data directory.
Okay, thank you.
Mm-hmm. So if we just wanted the station name that was hottest, we would say, okay, well, the hottest thing we're going to get from reports, but to get the station name, we need to join with stations. So how are we going to join these 2 tables? Well, the reports table has a station ID, so we will say these are joined when the station ID matches. And what if we just said, all right, give me the station name, and how about the temperature, and maybe the time of the match too. Let's save this and run it. There we go. Now our next example here was, what about the weather station with the coldest record? So probably anybody think of a real tiny little change we can make to do this?
Switch it from descending to ascending.
Exactly, yep. Just ascending instead of descending. And what do you know? Chicago is very hot and very cold. Wonderful place to live. Okay, and hottest and coldest record for each statement in a single query. So this is an entirely different kind of query. We're saying for each station, when the business analyst or the, whoever the boss is that says to you sometime, hey, can you answer a question about how many users this, or whenever they're asking some sort of question and you're going to need to go into the database and find out an answer. When you hear for each something, you're probably going to deal with a group by there. So for each station. So that makes me think the primary thing we're looking for is a station. So when I actually write out a SQL statement, I often start with like, what is the primary thing I'm working with? So I'm going to select from stations. I don't know what I'm going to select yet. So, okay, so for each station, okay, hottest and coldest. So hottest and coldest, that means the temperature. Well, the temperature is in the reports table. So I'm going to need to join those together. And let's see here. So stations ID equals reports, that station ID. Okay, so now we have all the stations joined all the reports and we have the temperature available, hottest and coldest. All right, well, hottest and coldest, that sounds like max temp and min temp to me. Now, it might be nice if we actually had the name of the station too. So I'd probably say like stations.name. And if we try and run this right now, it's going to whine at us because, yeah, we need to group by. So remember our for each station. So we'll say group by stations.name. And there we go. In one query, we now have the highest and lowest temperature recorded.
And so why does it have to be grouped by? Like, why does it not work without it?
Yeah, so if we don't have the group by, well, okay, when group by tells us how many and which buckets we're going to use, how many different groups. If we don't tell it group by, we're saying there is only one bucket or there's only one group. Well, if there's only one group, which station name should we put there? It could be Jacksonville or it could be Chicago. We're trying to smash two values into one. And it's going to tell us, well, we can't do that. We have to tell it how to, either group those things so they're in separate buckets or how to reduce those things to a single value.
And that seems like it's pretty self-critiquing. I'm assuming like there's really no, like you don't necessarily need to know when you need to do it because it's pretty much going to tell you every time.
Well, yes, it will tell you every time. Like if you ask it like an invalid query like that, it will throw an error and stop you. But it is something you kind of do need to know that ahead of time, like why you're doing that. That idea of, in this particular example, for each station. That's the, it's kind of like a story problem in math. This is the thing that informs us. We want a group for each station. So that's why we're going to do, group by station's name. We want a new group for every station name we run across. And usually like that'll be part of like, as you're thinking through the process of the query, you're thinking like how many, what rows do I want to come back? Well, I want a row to come back to have the name of the station and I want it to have, the max and min temperatures. And if I need the station, I need one row for each station, but there's a couple 100,000 report rows. I need some sort of way of either, dividing them or grouping them or reducing them.
Thank you.
Mm-hmm. Let's see here. Dennis, looks like you have your hand up.
Yeah, can you do that same example the same way you just did it one more time, please?
You mean just like just build the query from scratch like that?
Yes, please. Thank you.
Yeah, sure. So I look at this and I see, okay, what is the data? What am I trying to find here? So the relevant things here is hottest and coldest. So that makes me think, one, we need temperature. So we're going to need, the reports table. Hottest and coldest make me think min max, it's the biggest and lowest numbers. But then the for each station, that makes me think, what do I want to come out of this? Like we already have the answer here, so we can kind of just visualize this here, but I want a row for each station and I want the station name and I want the high and low temperature. So the way I tend to build these things is I usually have something in my mind of like, this is the primary table that like anchors this query. So we've been doing stuff with only one or two tables. If there's one table, obviously that's the only one. If there's two tables, there's still usually one table that is kind of the anchor or the core thing. Like if back in our phone book thing, if we were saying, give me all the phone calls we've made, well, we're going to want calls and we're going to want contacts, but calls is kind of the primary thing we're saying. Calls is the primary entity, and then we join it with contacts to say who the name is. So for here, since we're saying for each station, that makes me think that the primary thing is stations. So oftentimes when I'm building something, I'll actually just start here. I'll just run it. I know this isn't right yet, but I just run it after every little step. That's another thing that's really, really important, not just in SQL, but in just programming in general. Do the smallest possible step you can. So it's like, this is the simplest query I can write that's a step the right direction that'll actually do something. So even though I've done this, I don't know how many thousand times, I know what it's going to do. I still, as often as not, will just do this, run it like, okay, it works. You know, the t.SQL is the place where I think it is, the /i works, everything's working so far. Then I know based on that I'm looking for temperatures, well, I need the temperature, I need the report table. So let's see, let's join reports on stations.id equals reports.station.id. And maybe I'll just run this one too, just to see, okay, it's working so far. Then what do we got here? Okay, so for each station. So I've got a ton of rows here. Like about 200,000 rows, actually. I need some way of getting them down to one row, or one row per station. So when we say one row, you know, something per something, that's another one. When you see, you know, for each, or you hear like per something, that's a good sign that maybe there's a group by. Not always, but that might be the type thing you start thinking. So since we're trying to come up with one row per station, that definitely makes me think I'm going to group by something stations. And since what we want to come out is the name, we'll group by station name. So let's just do this here. Again, smallest step that'll actually do something. Okay, now we got their name. We still have this reports table though, and reports has temperature. So we can say, how about it gives me the max temperature? Great. Okay. Let's also ask it to give me the minimum temperature. Cool.
Would it work if you on line 3 you didn't indent join, or is that like mandatory?
Yes, it would totally work. Spacing, aside from the fact that, like, you know, this will break because now it doesn't know it's two words. But aside from that, you know, spacing doesn't matter at all. So there is no one standard way of formatting SQL, but there are several, you know, broadly used guidelines, and then kind of everybody comes up with their own, you know, exactly the way they write it. For me, what I tend to do is every significant like primary clause gets on its own line. So select is a major thing, from is a major thing, group by is a major thing. Join is actually part of the from clause. So because it's part of the from clause, I'll indent it. And if, for example, we had a where clause, I'll just make up some stuff here, you know, where if there was something like this where, you know, I don't know why we would, you know, obviously that doesn't really make sense, but if there was multiple conditions in the where, then when we say and this or that, all that sort of stuff, I tend to indent that as well. So you end up with the primary stuff all the way to the left. And another way of doing that is like if we had a bunch of columns, like if we were selecting like 20 columns or even like 10 columns, it becomes easier to read vertically than to just have them all scroll off to the right. So I would end up, you know, doing something like this. But it is all, you know, the computer doesn't care. This is just so we can read it easier.
Sorry, I have one question.
Mhm.
I don't know if you talk about this, but I'm struggling to understand when do I have to say which table I'm calling the thing from. Like, it's when it's necessary to write the stations.name or when I can just say just name.
So you can, whenever there is no ambiguity. So this will work.
Okay. Yeah.
Right, like in this case, so the only ambiguity on this one, actually, I guess, is the ID column. Because both tables have ID, but they do not have any of the other ones. So it kind of just depends on whether, if you're writing it for long-term usage, you may end up fully qualifying the names if you think there's a chance of collision in the future. Name is so common that as often as not, half your tables have a name column. So I just kind of tend to do it there, but yeah, it's only necessary in this particular example for .id.
Thank you.
Mhm. Okay. So here's an interesting question. Can we, based on the information we have, can we find the average wind speed for each day at each station?
I think.
What's the code again, just to get the columns for that table? Is it just,
\D and then the table name.
okay,
I mean, I think we should be able to, based off reports time.
Yeah, let's, we've got this query here. There's a couple new things here. Given that I prefer not to type too much more than necessary, group by and order by, if you just give them a number, that means that column number. So this is group by column 1 and column 2, order by column 1, order by column 2.
Those are the columns that you're specifying, that you're selecting, not the columns of the whole table, right?
Correct. So let's run this. I mean, this actually looks right in a sense. So we got the station name. This is probably a construct you haven't seen before. That is a type conversion. So we are saying convert the time to a date. So just give you an example what that looks like. And the reason we're doing that is so we can group by the day as a whole, not every minute we happen to get a report. So let's run this. It looks right. Name, date, average of wind speed. Looks good to me. And we get numbers back. Excellent. All right, though. Here's the big question. Is this correct enough? Why or why not?
well, you scrolled through that pretty quickly. Was that actually the average per day?
Well, that's what we're trying to figure out. We asked Postgres a question that seemed to be average per day, and it gave us an answer. But I want us to double check this and see, did we actually ask it the right question? Is the question even answerable? That's what we're trying to figure out.
Are there any null values?
Let's see.
I mean, there's only 3 days. So we should have only gotten 3 rows.
Yeah, let's see here. So let's just scroll through some of these reports. Oh, as far as are there nulls, we can actually see that. Let's look at reports. We don't even have to scroll through for that. So wind speed can be null. Okay, let's figure out, do we have any? Jake mentioned before this construct of is null. That's how we can test is something null. And yeah, okay. We do have 140 out of 200,000. Isn't that wonderful? That's one of the reasons you use not null constraints, to avoid messy situations like this. It's always fun when you're asked for a report and there's like always just a little bit of dirty data. So that's a little bit of a problem for us. It may or may not be fatal, because remember we talked about null meaning unknown, and just like count, average, and almost all of the other aggregate functions, they just ignore null. They don't include it. So we could say, okay, if we eliminate all the things we don't know, it's almost as if these rows didn't even exist. So it may or may not be that big a deal. Let's look at these some more. In fact, let's just look at this first. Let's just look at this first day for whatever station ID 94846 is. All right, let me just scroll this up a little bit so we can see the whole day. So based on this data here, can we figure out what is the average wind speed for January 1st, 2010?
Around 300.
Oh, well, wind direction. I was saying wind speed, but yeah, I mean, that'd be about the average for wind direction. But I guess it actually works for either one. Let's see, there's a little bit of a trick here. I'm trying to figure out how to word the question. Or I guess you can probably gather based on me just pausing here. There is a reason that we're not able to answer this to a high degree of accuracy. So let's take a look at this. Just add this one here of how many samples we have. Just added one thing to that previous thing. So on January 1st, we had 27 samples. That's kind of the key question there. When we say, what is the average of things? We are looking at the average based on the samples we took. Well, how often do these, looks like these things are roughly an hour apart, usually. Well, who knows? We could have had a tornado in that hour. You know, it might have been, 1 in the morning, it might have been a wind speed of, 10. By the next hour, it could have been 11, but it could have been 75 for a few minutes in between there. Maybe at 2:30, there was a hurricane coming through or something. So when we say this question of, is this correct enough? Well, how much accuracy do we care about? It's actually unlikely, especially for wind direction. There might be gusts of wind, but the wind probably doesn't change entire direction. So we're probably safe, more or less, averaging wind direction. Maybe we're safe averaging wind speed. But we do have to understand, what are we doing here? We're actually averaging a sample, and that's you know, we are introducing error here. This is not something we can do foolproof. Here's another trick. I'm looking at this and I'm thinking like, wow, this is great. Okay, so we get a sample every hour for whatever reason on the 51st minute of every hour. Okay, whatever. Great. So our samples are evenly distributed. So great. Oh. So for some reason, we took a sample 9 minutes after the previous one. So 5:51 and 6. And it looks like we do the same thing at noon. So it looks like we take a sample every 6 hours and every hour on the 51st minute. Sure, why not? Well, at least that's what we did on January 1st. Let's go back to this thing of count samples. Apparently we did something a little different on the 2nd, a little different again on the 3rd, a little different on the 4th, way different on the 7th. Why? You know? So in other words, that makes our sampling even more tenuous because, you know, it's one thing if they're evenly distributed, but these two being so close together would be definitely biasing our average. So, you know, this question of is it correct enough, why or why not, you know, enough is really the thing there. If we just care about roughly what happened on that day, we're probably fine. If we actually care to be a little more accurate, or we really want to be precise about what we're doing, then we may just not have enough information to, you know, really do this. You know, we might need to do, you know, we either say we can't do it, or we need to do some additional like corrective measures of, you know, some sort of biased sampling or something, you know, to, you know, you'd have to talk to some statistics people to figure out exactly how to answer this question. So most of what we are talking about here, it's not that we really actually care about this question. What I was actually trying to get everybody to think about here is, on this day one of SQL, I know everybody is mostly thinking about, how can I type something in that Postgres won't complain to me about? You know, if it compiles, it must work, right? You know, but especially when you're trying to get reports that, you know, people are going to make decisions on, it is really, really hard to make sure you are asking exactly the right question and that you have the right data to do it with. And basically just trying to, kind of like we talked about with time, saying, you know, dragons be here, be careful. This is the same type thing here. Even this little simple thing with 2 tables and a handful of columns, we might think, oh yeah, I just wrote the thing, I averaged this, we're all good. And we didn't actually do what we thought we did. So whenever you go into like reporting stuff, that's kind of just a beware type thing. We are about out of time on this. It is about time for me to turn this over to Jake for the data modeling thing. So I'll just mention there are a number more of fun queries we can do on the weather here. Plus there are those other entire 2 lessons, and there are solutions, like I said, to all the exercises. So if you're interested in this stuff, you know, there's a lot more to go. But like I said, we need to change direction now. We are going to do some data modeling with Jake, and I think we're going to take a break, but I'll turn this over to him now, and then he can tell us like when we're going to start again.
Yeah, why don't we take 10 and we'll meet at 5 after, and then we'll probably, yeah, we'll go for that hour and then go into Q&A.